Okay, class, so here is an extra example of the average velocity, instantaneous velocity type problems for those of you who would like to see another one if just seeing one of them wasn't enough to help you out. So you're going a little more general here than a rock falling. This is just the position of an object moving along a line is given by the function s of t is equal to negative 5t squared plus 30t plus 20, and that's in meters at t minutes. Right, so its position at t minutes is given in meters is given by this function. So we want to find the average velocity of this object over the interval 0 to 2, so 0 minutes to 2 minutes, so the first 2 minutes, and the average velocity from 2 to 3, so from minute 2 to minute 3, and then we'll find the instantaneous velocity at t equals 2 minutes. Right, same sort of problem we saw before, just different numbers, different function, all that. So let's start by finding the average velocity of that function on that first interval, so from 0 to 2. So, and since we have velocity now, I guess I could just say average velocity from 0 to 2 of s of t. Well, remember, if we go back to our definition of the average rate of change, this is something you should probably remember, but as you're learning, if you write it each time, you'll write it down in no time. That's f of b minus f of a all over b minus a. So this is going to be, let me shift this down a little bit. It's going to be s of 2 minus s of 0 all over 2 minus 0. Now, again, like I said before, you can invert these if you want, as long as you stay consistent. If you want to do s of 0 minus 2, you have to do 0 minus 2. Okay. They should match. And let's not do that again. If we go back to what our function looks like, remember it's negative 5t squared plus 30t plus 20. So this is going to be negative, I'm going to put it in parentheses, my s of 2. It's going to be negative 5 times 2 squared plus 30 times 2 plus 20. Right, so that's s of 2 minus all of s of 0. Now, it might not make that big of a difference here, but I always put both of these in parentheses just so I don't make any mistakes. Right, so this will be negative 5 times 0 squared plus 30 times 0 plus 20. And this is all over 2. And yes, this is how you're supposed to write things. A lot of people will just simplify this numerator and then later add in that 2. That's not correct. You've got to write this fraction out every time. No whining, just do it. Okay, so let's simplify this out a bit. These guys zero out, right? No problem. And I'm just going to write it out explicitly. Negative 5 times 4 plus 60 minus, and make sure this negative sign affects everything, but here it's just going to affect the, whoops, I forgot the plus 20 here. It's just going to affect that 20. So we'll get 20 minus 20, and we see that those constants cancel out there. Happens every time. So this is going to be negative 20 plus 60 all over 2. So we have 40 over 2, which ends up being 20. And 20 what? Well, the units of s were in meters, right? So s was on top. And the unit of t is in minutes, right? So it's meters per minute. So from t equals 0 to 2 minutes, this object has an average velocity of 20 meters per minute. And that's how you can interpret that if you're asked to interpret the problem. Right? In the first 2 minutes, the object has an average velocity of 20 minutes, or 20 meters per minute, excuse me. Okay. All right, let's find the average velocity from 2 to 3. That's the next piece. And this is done in much the same way. The average velocity from 2 to 3 of s of t, okay, is going to be s of 3 minus s of 2 all over 3 minus 2. Okay. So this is going to be, we're going to plug in 3 to our function, so it will be negative 5 times 3 squared. So remember what our function looks like here. It's negative 5t squared plus 30t plus 20. Be negative 5 times 3 squared plus 30 times 3 plus 20, and minus all of plugging in 2. So this is s of 3, okay, and then this is going to be s of 2. S of 2 is negative 5 times 2 squared plus 30 times 2 plus 20. Right, all over 1. And so actually this fraction disappears, thankfully. And so now, and we are going to have negative 5 times 9, which is negative 45, plus 30 times 3, so that'll be plus 90, plus 20. And then here, make sure you change the sign of all 3 of these. This is the biggest mistake I see, or maybe not the biggest, but the most common mistake I see on this every single time. People forgetting to distribute that negative sign. Distribute the negative sign. Right, let me write it here in big letters. Distribute the negative sign. Okay, so that's going to make that, well, this is negative 5, but the negative negative makes it positive 5, so 5 times 4, which will be 20. Okay. Plus, and we're changing that to a negative, so since we're changing the sign, that will be minus 60 and minus 20. And so the 20s cancel. Those 20s should cancel. They are the constant terms. They should definitely cancel. Okay, and what we're going to end up with when we crank this out is going to be 5. Okay, 5 meters per minute. And sorry about that, it's another camera issue. So we get 5 meters per minute. So from t equals 2 to 3 minutes, right, the object has, this is all slanted, has an average velocity of 5 meters per minute. All right, now the last piece is to find the instantaneous velocity at t equals 2 minutes. All right, so let's calculate that. All right, so the instantaneous velocity, I'll just call IV, at t equals 2, s of t. Now, in the next lecture, we're going to get a much better way to talk about this. Those of you who have seen some calculus before probably already know what that is. But for the time being, I'm just going to use this notation. The instantaneous velocity of s at t equals 2. Well, remember, the instantaneous velocity, if you remember the definition, is this limit. So whenever you see that word instantaneous, okay, instantaneous means the limit. If you see average, it just means the slope idea without the limit. Okay. So this is going to be the limit. Shift that down a little bit. This will be the limit as h goes to 0. I'm just writing out the definition, s of 2 plus h minus s of 2 all over h. And we're going to simplify this out. Okay, calculate this limit. So the limit as h goes to 0 of s of 2 plus h, well, that is going to be, if we remember what our function looks like here, that's going to be minus 5 times 2 plus h squared. I'm going to put the whole thing in parentheses here. Plus 30 times 2 plus h plus 20. And hopefully I have the room. Minus s of 2. So s of 2. So here, let me say that this is s of 2 plus h up here. Just as a little sidebar note. And this is going to be s of 2. So it'll be negative 5 times 2 squared plus 30 times 2 plus 20. All over h. All right? So this is s of 2. Now I put the whole thing in parentheses. I suggest you do too, both pieces, just so you don't make any mistakes. All right? So now we're going to FOIL this stuff out, and well, let's see what we get here. We're going to get negative 5. We FOIL this out, it'll be 4 plus 4h plus h squared. If you aren't as well versed in foiling as I am, that's okay. I've been doing this a lot longer. If you have to expand it out, go right ahead. Then this will be plus 60 plus h, okay, plus 20. Right. And this is going to be, now remember, distribute this negative sign across, change all your signs, and I'm going to write it like this. This is going to be 5 times 4, and you'll see in a second why I'm doing that, minus, okay, 30 times 2 minus 20. Okay. And actually, I guess we don't have to do that, right? This is going to be 20. But the reason I want to show it is because this is actually going to cancel with this, but I want to actually show where things specifically cancel, even if they don't match, right? And remember, this goes all the way over h. It's easy to forget that part, but always write that over h. Okay. So, writing this next step out, I'm going to distribute that 5. So I get negative 5 times 4 minus 20h. I'm going to go ahead and multiply that one out. Minus 5h squared, and it will be plus 60 plus 20 plus 5 times 4 minus 60 minus 20. And here's why I left some of these alone, because I want to show that the constant terms cancel, okay, and not just that, but these 5 times 4s cancel. And that's always pretty much going to happen, even if they don't match with the constant term like they happen to here, right? These 60s cancel, right? Basically, you're left with only h terms at the top, and that's always what's going to happen. Right, so this is going to be the limit as h goes to 0. It's going to be negative 20h. Oops, sorry, typo here. that should be 30h sitting there. And I forgot it in here as well. There should be a plus 30h right there. Sorry about that. So when we join these together, this is negative 20h plus 30h. So it should be a positive 10h. I'm very sorry about that. Minus 5h squared all over h. And we get to this point where I always say a lot of people just want to start canceling. Again, if you're good at math and you're confident, you already know that this h cancels with both of these. The two h's up here leaves an h here. But a lot of people have trouble with this. They screw things up. They cancel incorrectly. And the rule is, if you can factor an h out of the top, which we can, and we're left with a 10 minus 5h all over h, then it is 100% clear which things cancel. Right, so we get the limit as h goes to 0 of 10 minus 5h. And as h goes to 0, 5h goes to 0, bam, cancels out and becomes 10. Okay? 10 what? Very easy to forget, but if we go all the way back, the units of S are still in meters. Now, what about this? This is still a difference in T. T is going from 2 plus H to 2. So this is still in minutes. So this answer is meters per minute. Now, if you are ever asked to interpret a rate of change, it's always a fraction. Always. Why? Because rates of change are always fractions. No matter how you decide to write a rate of change, it is a fraction. So whenever you interpret it, it's going to be units of your y's over your units of x's, your units of s's over your units of t's. That's always, always, always how they are interpreted. Okay? So, the instantaneous rate of change, or the instantaneous velocity of this object at t equals 2 is 10 meters per minute. Now how we can write that is we can actually just say that at t equals 2 minutes, the velocity, or actually I could write it like this instead. I can just say that the object travels at a velocity of 10 meters per minute. Okay. Again, this is the difference between looking at your dashboard, looking at the speedometer and seeing 10 meters per minute, which you wouldn't see in a car, and telling someone over the first 2 minutes I was traveling at about, I forgot what the answer to that other one was, but let's say from minute 2 to 3, I was traveling at about 5 meters per minute, right? That's the difference between these two. So the instantaneous velocity actually lets you say what the velocity is at a particular minute, at a particular second. And that is what makes this so powerful, that we can finally take any kind of crazy function we want and talk about its rate of change at a particular second, at a particular minute, at any particular time we want to talk about, at an instant. And that's why it's called the instantaneous rate of change. Okay, so there's another example for you, and we'll continue this discussion about instantaneous rate of change and what that actually means in terms of what we started talking about, which is this derivative, in the next lecture. All right, cheers.